Hello friends, I am back with one more video on number theory factorials. In this video I will be sharing some of the important concepts and the questions which are going to appear and which are appeared in the previous papers of various competitive exams. First of all, let me introduce about what is factorial. Factorial, it's an important topic as we can see in various, as mentioned earlier. Factorial topics finds application in permutation, combination, probability and number theory, etc. Factorials is defined as a product of a consecutive numbers. We know all that addition of the numbers. Now we also have a formula to find the product of the consecutive numbers. It can be simply defined as product of n consecutive natural numbers from 1 to n. Let's consider 7 factorial. It's nothing but product of numbers from 7 to 1. We get it as a 504 by normal multiplication. I suggest you all to memorize these factorials so as to they come in handy in fast calculations in various competitive examinations. Let's look at some of the commonly asked questions based on the concept of factorials and the number of trailing zeros in various competitive exams. First, it is finding the highest power of a number in a given factorial or a product, number of zeros in the end of a factorial or a product, number of factors of any factorial, and also finding the highest power of a number in a factorial or in a product. First we will know what do we mean by highest power. Now consider, for example, there is a number n. It can be represented in the form as p raised to 2 into k raised to 1. Here the highest power of p in n is 2, the highest power, and the highest power of k is 1. To find the highest power of a factor in a given factorial, we need to go on dividing the number by whose highest power of a factor is to be found. We will keep on approximating the quotients obtained after each division and add up at last. The result obtained after adding all these quotients is known as the highest power of a given number in a factorial or a product, we can say. Now let's look into some examples. If the question says find the highest power of a 5 in 30 factorial, we need to go on the given number 30 factorial by 5. Here the process goes like, we go on dividing 30 by 5. 5 are 5 6 are 0, 5 1s are. We need to add these quotients, that is 6 plus 1 is 7. We got it here. Therefore the highest power of 5 in 30 factorial is 7. Example 2. Find the highest power of 2 in 50 factorial. The solution remains, the method remains same, but only the values are changed. We go on dividing the 50 by 2 and we add up the quotients, that is 25, 12, 6, 3, 1. Add up the quotients, we get 47. So the highest power of 2 in 50 factorial is 47. Hope you understood. Now what is the highest power of 5 such that the number divided by 125 factorial. Solutions goes like this. Go on dividing 125 factorial, 125 by 5 by the 5 powers, 5, 25, 125. This is the other method, but you can also go by the normal method by dividing the 125 by 5 and adding the quotients as shown earlier. If we go on adding the quotients, we get as 25 plus 5 plus 1, that is equal to 31. Therefore the highest power of 5 that divides the given number 125 factorial is 5 raised to 31. Fourth question. Find the highest power of 3 in 100 factorial. The solutions is the method remains the same. Go on dividing the 100 by the powers of 9 successively. 100 divided by 3, 100 divided by 9. In this question we have find the highest power of 3 in 100 factorials. The solution goes like this. Successfully as mentioned, sorry for go on, that we get 33 plus 11 plus 3 plus 1. Go on doing that, we get as 48. Only the integral part is considered, whereas fractional part is neglected here. Same question with different numbers. Find the highest power of 2 in 100 factorial. Go on dividing successfully, we get as 97 factorial, 97 as the answer. Or find the highest power of a composite numbers in a given factorial. We go by, these are the 3 steps. First, factorize the composite number into prime factorization or canonical form, we can say. Find the highest power of all the prime numbers in that factorial using the previously mentioned method, and take the least power. This is the very important. Take the least power in this. Let's take an example. What is the highest power of 10 in 100 factorial? First of all, we need to factorize the two numbers, that is 5 and 2. Highest power of 5 is 24, as mentioned earlier. We can go with that same method. And highest power of 2 in 100 factorial is 97. Step number 3 states that the answer will be 24, because to get 10 you need a 2 pairs of 2 and 5. 2 and 5 require, and only 24 such pairs are available. So take the lesser value of the two numbers, that is 24 and 97. We take 24 as answer. What is the highest power of number 12 in 30 factorial? Factorize 12 in the prime factorization, 3 into 2 square. This is the prime factorization. Now find the highest power of 3 in 30 factorial. We get it as 14, and highest power of 2 in 30 factorial is 26. Now find the highest power of 2 square. We have found the highest factor of 2 in 30 factorial. Now we require the highest power. It will be reduced to, since here it is 26, it is reduced to 13, half of that, if we are finding the power. Now step 3 states consider the lowest of the two, 14 and 13. That is 13 is the answer. 13. Find the highest power of 72. Go through this. Now it's go through the questions. Highest power of 72 in 100 factorial. First of all, factorize the numbers. The process remains the same. Only change is the values. Please do it by yourself. Now finding the let's move into another concept, finding the number of zeros in the and of factorial value or a product given. We all know that the zero can be formed only when it is multiplied by 5 and 2. When we get the pairs of 2 and 5, we get 10. Therefore it's nothing but effectively finding, since 2 is a very less number and 4 can be expressed as 2 squares something. Therefore we take only finding the 5. In this method we need to find the highest power of 5 in the factorial by successive division. Find the number of zeros in 30 factorial. 30 factorial can be given number of zeros in 30 factorial is 30 divided by 5 plus 30 divided by 25. 30 divided by 5 is 6 and 30 divided by 25. Consider only integral value. We get it as 1. Therefore 6 plus 1 is 7. Therefore number of zeros in 30 factorial is 7. Similarly, the number of zeros in 100 factorial. 100 divided by 5 plus 100 divided by 25, we get it as 24. Find the number of zeros in 250 factorial. Go on dividing successively. 250 divided by 5 is 50. 250 divided by 25 is 10. 250 divided by 125. The process continues unless and until the numerator is larger than the denominator. If the denominator exceeds the numerator, then the process stops. Therefore we get it as 62. Example number 4. Now find the number of zeros in 15 factorial. Go on dividing the number 15 by 5. It's simple once you get used to it. Since 15 by 25 is very less than 1, neglect that. Therefore we only consider the first term, that is 15 divided by 5 is 3. Now let's look into another concept which is mainly asked in various competitive exams such as CAT, MAT, GMAT. It may be asked in any examinations. It's better to understand it and learn and use it and apply. To find the non-zero digit from the right, that is, if a number is 5 factorial, 5 factorial is nothing but 5 into 4 into 3 into 2 into 1. We get it as how much? 120, I think so. 120. We have found the number of trailing zeros ending 8. Now if the questioner asks find the non-zero digit from the right, then the method goes like this. First we need to first of all divide the number by 5, represented in the form shown below. This is the form. N is equals to 5p plus 5 into p, that is 5p plus k. Now we have the formula for finding the right in n factorial given as 2 raised to p. Remember it, 2 raised to p 5 factorial into k factorial. You may ask why you have used p and k. These are my initials, Praveen Kumar K, so as to get used to it. Rightmost digit in n factorial is given as 2 raised to p into p factorial into k factorial. Let's take example 1. Find the rightmost digit in 6 factorial. Once we divide the 6 by 5, we get it as, in terms of this, that 6 can be represented as 5 into 1 plus 1. Note down here the given number is n is 6, n is 6, and p is this part, p is 1 and k is 1. Rightmost digit is, as I mentioned earlier, 2 raised to p into p factorial into k factorial. 2 raised to 1 is 2, 1 factorial is 1, 1 factorial is 1, 1 factorial is 1. Therefore we get the rightmost digit as 2. 6 factorial. Normally you use the calculator and find out the 6 factorial. You will be getting it 120, I think so. Yes, you will be getting 120 factorial. 120 into 6, that's 720. 720. The rightmost non-zero is 2. Hope you understood this. It's simple once you understood this concept. Example 2. Find the rightmost digit in 11 factorial. The process remains the same. Go on dividing the number 11 by 5. It can be expressed as 5 into 2 plus 1. Now here n is given, n is 11 and p will be 2 and k is 1. Applying the formula, rightmost digit is 2 raised to p into p factorial into k factorial. 2 square into 2 factorial into 1 factorial. 2 raised to 2 is 4 into 2 is 8. Example 3. Find the rightmost digit in 90 factorial. 9 factorial. Solution. Go on 9 factorial as 5 into 1 plus 4. Here n is 9, p is 1, k is 4. Rightmost digit is given as 2 raised to p into p factorial into k factorial. We get the answer as 8. Example 4. Find the rightmost digit in 24 factorial. 24 can be expressed as 5 into 4 plus 4. After the division of 24 by 5, we get it as this. N is 24, p is 4, k is 4. Rightmost digit. Applying the formula, we will end up with 16 into 24 into 24. 4 into 4 is 16. 16